Okay, so the next problem in the lead code we are solving is the leaf similar trees. Okay, so here we are given a tree, right? And here we can see the leaf nodes are highlighted. Okay, so we'll have to get the first foremost thing is we'll have to get all these leaf nodes. Okay, and basically we'll be given the two trees. Okay, so one will collect the leaf nodes from here, and we'll collect the leaf nodes from the tree two. Okay, tree one and tree two, and then we'll have to compare to see if both are similar. Okay, this is the question, and this is the to approach this problem, right? I thought of initially using the breadth first search. Okay, so we just need to get a leaf nodes, right? So thought of just iterating through it, and whenever we encounter a node without any child nodes, right, we'll consider that as a leaf node. Correct, that's how we can identify the leaf node in the breadth first search. So I thought of doing it. Okay, and then I got the leaf nodes also and everything, but there's a condition that it should be in order also. Like, I mean, when you go to the breadth first search, right, the order might be different. Correct, like we'll identifying this first, and then this, but order here is 67498 67498. Okay, this should be the order should be retained here. Somewhere there is mentioned that sequence is also the same. Okay, so that's why we cannot use the breadth first search here. Okay, as the order is same. So let's see that if we can use how we can use the depth first search. Okay, so basically when we say depth first search, it's a recursion thing. Okay, so we are going to break down the problem into the recursion wise. Okay, when we go to this node, basically we'll be splitting our task for a left subtree and right subtree in the recursion mode. Okay, so we can, okay, they have written a two recursion functions here actually. So let's just check this one. Okay, so this is the get lift nodes. Okay, so basically what we'll have to do ultimately is we'll have to get the leaf node for the root 1, get the leaf node for root 2, and then we'll have to compare it and send back the result. Okay, now let's see how to get the leaf nodes. So first thing is what we can do is we are using the DFS, right? Depth first search, we are doing it. So first foremost thing, we don't have any leaf set. Okay, and now whenever we are doing the depth first search, and when we encounter a node which does not have any of the child, right? So let's say that first foremost thing, if it is not none. Okay, let's say that if we are taking this root node, we do there is a chance that it can be empty also. Okay, list can be empty. So list is empty, obviously root node will be also the empty, right? We should be making sure that it is not a none. Okay, and then if it is not a left, if it is not a right, it doesn't have anything, we'll just read this value and append it to our leaves list. Okay, so that is one thing. And also if we don't, let's say that we are at the root node initially, right? If there is something, we'll just ask the next guy, like, I mean, we'll be doing the DFS on this node actually. We'll be sending that node there. So it similarly when it goes here, right, it will go here. Okay, at some point in time when there is no child node, we'll be updating the global variable. Like, I mean, it's a function one inside it, but compared to this one, right, it's outside this leaf node, right? So whatever the recursion level we are at, we still have the access to this. We can just update this one. Okay, so and also it will be in a proper order. Okay, so this is one way. Like, I mean, we can have it in the outside of the current DFS and keep on updating the leaf nodes. So another one way was, like, I mean, what we can do is we can, instead of having it globally, right, ideally we like, I mean, for this problem it's okay. Like, I mean, we can keep it outside and do it, but ideally we avoid ourselves, right, from recursion to use the make use of the global variables. Okay, so what we can do is whenever we approach a recursion problem, we should be confident, or we should be knowing what is the exit condition first. That is the foremost thing. Correct. So let's think about exit conditions. Let's say what is our exit condition. Whenever we hit a node, it should not have any branches, right? That is our exit node number one. Okay, like, I mean, exit condition number one, if not root out left and not root out right, we'll have to return the current node value. Okay, and also we are returning, like, let's say that we don't have anything. Okay, let's just forget about this. We just have this node. Okay, and we don't have anything else behind it. So what we'll have to return, we are expecting a list here, right, ultimately. So we'll just, so that's why we'll be returning this. And also forget everything here. So let's just assume that the root node is only this. Okay, we have given only one node, and what will be the answer? List of three, right? That's what we are going to return. So now we are good with the exit condition. And also one more thing is, let's say that there is a condition that root does not exist at all. Like, I mean, we just sent a root node. I mean, it's an optional actually. Like, I mean, it can be empty. Okay, that's what I mean. Like, it can be empty list. Okay, so if that is the case, what we'll have to do, we'll have to return empty list. So we are good with the exit condition. The same exit condition will apply here also, right? Whatever discussed so far, we just assume that we have only this, that will be applicable to this. Okay, so but let's say that we this root node is not a leaf node, we have subtrees. Okay, so in that case we'll be analyzing it again. We'll be just calling that again, and it will do the analysis and it will send back us the result. So finally we need to calculate the leaf nodes from left subtree and right subtree. We'll be just adding it. So once we get the result either from this function, right, either from this function or this function, we'll be getting the leaf 1 and leaf 2, and then we'll be comparing it and sending back the result. That's it. Thanks. Leaf similar trees. That's it.